we're going to find the average value and RMS value of this waveform, where maximum peak value is given as 100 voltage. This is voltage and this is time. So this is the maximum value, which is 100. There is a sinusoidal wave going from origin. It's starting from origin and it goes and reaches up to 10√2 voltage, maximum voltage. Then after 10√2, it goes on a constant voltage from pi/4 to 3π/4 time. So at 3π/4, starting from 10√2 to 3π/4, there is a constant voltage which is 100√2, and after it reaches 3π/4, the voltage again falls. That is, again it takes the sinusoidal waveform from 3π/4 to pi. So up to here there is again the sinusoidal waveform. So here the time period is given as, for first part, that is from 0 to pi/4, there is 100 sine omega t as the VA voltage given. From pi/4 to 3π/4, the voltage is 100/√2, that is a constant voltage, and again from 3π/4 to pi, it takes voltage as 100 sine omega t. So for this time period, we have to do the integration to find out the average value and the RMS value of the waveform given. As we know, the average value is given as the whole average of time, that is 1/t, and starting from which we have to integrate the whole waveform, that is from whole time period, for whole time period, that is for 0 to t, and the voltage given is Vm d omega t. That is how we have to integrate. For this Vm, we have to divide our voltage in 3 parts. So here we have divided the voltage from 0 to pi/4, which is a sinusoidal waveform where the peak voltage is 100 and there is a sinusoidal waveform. Again, for next part, there is a constant voltage from pi/4 to 3π/4, which is 100/√2. So we do 100/√2 d omega t. For the next part, there is a sinusoidal waveform again from 3π/4 to pi/4, which is 100 sine omega t. So we integrate that. So for integration, we know the integration of sine omega t is minus cos omega t, and 100 is a constant value. So we take the 100 out and integrate sine omega t, which becomes minus cos omega t. Integration starts from 0 to pi/4. Again, for the second part, 100/√2, both are constant values. So we integrate 1. The integration of 1 becomes omega t, which starts from pi/4 to 3π/4. And for the third part, again there is a sinusoidal waveform in which the 100 is constant value. So we take 100 out and integrate sine omega t. Sine omega t integration becomes minus cos omega t. Integration is from 3π/4 to pi. So for the solution, 100 becomes 100 minus cos pi/4 is again 1/√2, cos 0 is 1. So for the integration, there is 3π/4, we write it down the same way. And for third part, again cos pi is minus 1 and cos 3π/4 is 1/√2, minus 1/√2. So we write it like that. Here the value we write is, for this value it becomes 29 after calculation, 29.289. For this whole part it becomes 111.072, and for this part 29.289, same as the previous one. So we have got pi left here, so we write 169/pi, which becomes 54.001 voltage. That is our average value, average voltage of that curve given. Now to find the VRMS, we know the value of formula for VRMS is 1/t. The integration is from 0 to t, and we integrate for the square value of voltage, that is Vn square d omega t. So for integration, we all know how to do integration. 1 by pi, this is time period is from 0 to pi, so we write the pi 1 by pi outside. 100 sine omega t becomes 100 square plus sine square omega t. For the next half cycle, again we write 100 by root 2 square, and for the third part 3 pi by 4, 100 square sine square omega t d omega t. We write 1 by 2 outside because it would be easier to write 1 by 2 as a power rather than writing root over every time. So I write 1 by 2 on the power. So by integration 100 square, we convert sine. For this part, now we integrate the whole waveform. 1 by pi, 100 square comes out because it's a constant value, so we write 100 square outside. For sine square, we use the formula as 1 minus cos 2 omega t by 2 d omega t. Again 100 by root 2 square comes outside. We integrate 1 with respect to d omega t, and here 100 square comes outside. We integrate 1 minus cos 2 omega t 2, and the square root becomes 1 by 2 as a power. For integration, 100 square and 2 are constant values, so we write 100 square and 2 outside of the integration part. So we integrate 1 minus cos 2t only from 0 to pi 4. Here again we write the same, we copy it here, and for the third part 100 by 100 square by 2 are constant values, so we write it outside. For integration, if we integrate 1, it becomes pi by 4 for the higher value, and for cos 2 omega t we write it sine 2 pi by 4 for higher value, and minus 0 for pi by 4 which is the lower value, and here also we write 0 as the lower value of the integration part. Here 3 pi by 4, 3 pi by 4 are the same, it's just the integration of 1. And for the third part 100 square by 2, for higher value we write it up to here, and for lower value we write it up to here. So by calculating 1 by pi, the first term becomes this much, second term becomes 2500 pi, third term becomes same as the first term. So VRMS becomes 58.381 volt. We sometimes also have to find out the form factor and the peak factor. Sometimes the question would ask find the form factor and the peak factor of the waveform. So the formula of form factor is RMS value by average value. Our RMS value is 58.381, which is written on the top, and average value is 54.001. So by calculating, it becomes 1.0081. Again, for the peak factor, value by RMS value, the maximum peak value is 100, and RMS value is 58.381. We have just taken it out here. So after solution, it becomes 1.712. So this is how we solve the problem.